Hello, welcome to the Latinum Podcast. I'm Brendan, the co founder of Latinum, where we are building a frontier math lab that uses AI to accelerate mathematical discovery. One of the most exciting areas in AI right now is mathematical reasoning. Things kicked off in 2024 with DeepMind's AlphaProof, but over the last 6 months or so, we've seen frontier models claim an IMO gold medal and knock off Erdos problems that have been open for decades. A key driver behind this acceleration has been formal methods, and specifically the lean proof assistant. This is why I'm thrilled today to have Leo de Moura as our first guest. Leo is a principal applied scientist at Amazon in the automated reasoning group. And more importantly for today's conversation, he's the creator and chief architect of Lean. Leo, thank you for joining us.
Thank you. Thank you for having me here.
Well, let's just jump right in. As I mentioned when we spoke before, keen to just get the origin story of Lean and where you see it going in the future. But it would be great just to understand a bit more about what gap you saw in the world that made you think that this new programming language in the early 2010s was needed, and maybe what were the issues with the existing formal languages that were already out there.
Yeah, I have been working in automated reasoning my whole career. Right before Lean, I was working on an automated prover called Z3. It's fully push button, and Z3 has been used in many bug finding tools at Microsoft and many other companies. All big tech companies have used Z3 in some capacity. But Z3 is push button. There's no interactivity. It's fully automatic. For bug finding tools was very popular. But at Microsoft, in many other places, they also have used it. They try to use Z3 for software verification. But software verification, you are in what we call undecidable fragments. The solver, Z3 in this case, has heuristics. And for simple things, proving simple things, it works really well. But when the complexity crosses a threshold, it becomes really unstable. Unstable in the sense that you prove something, you're happy. Then you make a small change. You wrote A and B and you replace by B and A. You just swap. But it affects the heuristics and the proof breaks, and people are really frustrated. I mean, I had many users complaining. I remember at the time there was a guy came to me saying, "Come on, man! I know the proof. I don't need any help. I mean, I just want to convince the system that my proof is correct." That's how Lean started. It's like to fill this gap. I mean, make sure that we would have the automation we get in Z3, and we also have interactivity. AI was not a thing in 2013, right? I mean,
Yeah.
the interactivity was for humans, but it's really cool today that the interactivity is for AI too, right? I mean, AI uses Lean. I mean, all these gold medals and others problems. Who was driving Lean there was AI, not humans, right?
Yeah, that's a good point. We'll get to that a bit later. So it sounds like the origin really was driven by people frustrated with the existing
Yeah,
alternatives. So I guess like a good startup today, Leo,
yeah, yeah.
you had you had a hair on fire problem and you a good first user base. I guess in those early years, when you're creating anything new, it's hard to get your first users. Did you just go to these people who'd had challenges with it and say, listen, the first version is out, I'd like you to test it? Or was it hard to get adoption when people were used to using tools like Z3?
Uh, Interesting. This thing was not getting users, but understanding the landscape. I spent lots of time talking to people. Uh, uh, Josh Gautier, for example, was a colleague of mine at Microsoft Research. He was a power rock user, right? He did the four color theorem. He
Yeah,
was doing Fate Thompson. He provides a lot of feedback. I learned a lot from the rock world from George, right?
yeah,
From Isabel world, I learned a lot from Jeremy Avigat. I mean, he's a power Isabel user. He knew a lot about rock too. He was a visitor researcher with George. And so they knew each other. And so it was great to have Jeremy's feedback because he was both an expert in Isabel and rock. But I talked to many other people, right? I mean, the Daphne developer Russell Lehman is at Microsoft Research. He was using
Yeah.
Z3. There's the F-Star folks, Nikhil Swami. F-Star also uses Z3. I mean, it uses dependent types. I read all the documentation for whole lights. I mean, PVS. I mean, I worked for SRI before I joined Microsoft Research, and so I knew a lot about PVS. They're all my friends. I mean, I knew the capabilities. I started learning. The first step was learning about proof of systems, right? I mean, I
Yeah.
was. It's embarrassing that I worked for SRI, but I was not a proof of systems guy. When I was there, I was a SMT solver, like a SMT. What is the area where Z3 is?
Yeah.
So I was into SMT solving set solvers when I was in model checkers when I was at SRI. But I knew all these folks. I mean, and then but the first user was Jeremy. I mean, Jeremy was from day one using Lean. I mean, after like 4 months we were developing. Sunho Kong and I. Sunho was my intern at the time. After 4 months, Jeremy was using Lean. I mean,
And he became a power user quickly and gave you lots of
oh yeah,
feedback,
yeah.
I guess.
Oh yeah. He then his students, then uh, uh, 1.5 year later, uh, uh, Ed Clark was Sunho's advisor. Ed Clark is a Turing Award winner, and yeah, I had a good relationship. It's a pity he passed away, but he was always very supportive. I mean, he said, "Let's teach a course at CMU using Lean," and it was great. I mean, we had interaction with many students. Tom Hales, that is a very influential mathematician, came to the core. Every single lecture he came. I mean, uh, and he started advocating for Lean too. I mean, Tom Hales.
Good. It sounds like early on you had power users, you had amazing contributors and people that you kind of advise you in areas that you may not have known as well. So it's the ideal starting point, isn't it? Is
Yeah.
there anything going back to the origin that you do differently? You know, going back to 2013, if you were if you had a time traveling machine, or do you think it evolved as it was supposed to, and it just got better with iterations and new versions?
Well, if I could go back with everything I know, it would be very differently. I would have it would be much faster, right? I mean, I was
Okay.
learning. The first version of Lean is not great at all. I mean, you are learning, and I basically had to throw away. Then do version 2, it's a little bit better, but still not great. I mean, and you keep improving, right? I mean, yeah, I
Yeah.
wish I could go back in time with AI and have AI to help me develop it. I would move so much faster.
Yeah, I think we all would do things slightly differently in that
Yes.
scenario. But yeah, so I guess the one thing would be speed, which is interesting, and I guess that comes later with Lean 4,
Hmm.
right?
Hmm.
Cool, that makes sense. You mentioned Gontier and others who'd used Coq and other proof assistants. I think he was one of the first to do a big math project with the four color theorem you mentioned. Um, what was the kind of turning point where the math community moved towards Lean?
Yeah, yeah. Like for 2017, we just have real mathematicians using proof assistants. I mean, this is not the right word. I mean, they were not popular in the math community. You had computer scientists that knew a lot of math. I think that's the right framing. I mean, you had people that are very inclined. They're actually in computer science departments. They were using proof assistants. People like Tom Hales were exceptions, right? I mean, he used proof systems for formalizing the Kepler conjecture, the proof of the Kepler conjecture, but he was an exception, right? I mean, it's not was not popular at all in the math community. Proof systems. Then people ask me all the time, well, why Lean became popular with the math community. I think one thing is that we listen a lot about I mean, we took seriously the feedback. I mean, they gave, right? I mean, for example, the math community wants classical mathematics support, right? That's what they use. I mean, trying to tell them, oh, you should use constructivism, it doesn't work. I mean, you have now two problems. You're trying to convince a community to use a proof of system that's a new kind of technology, and you're telling them to change how they do math. It's not very popular. Uh, Tom Hales had a key role, I mean, in Lean's success, right? Because he launched this project called Formal Abstracts in 2017, and it attracted Kevin Buzzard's attention, right?
Hmm.
And Kevin had the position that's really important. He said, we should formalize modern math. Nobody, he said, Faye Thompson is a cool result, it's important, but nobody cares anymore. We have to formalize math that people are doing right now in a PhD program, what people are studying right now. And that's made a big difference, right?
And that led into the Zena project and the big investment from Kevin in that area.
Yeah, he starts. The first project he did was perfectoid spaces. He formalized perfectoid spaces in Lean with Patrick Massot and Johan Commelin. The perfectoid spaces, I mean, Peter Schozer got a Fields Medal. I don't know exactly the year, 2018. He got a Fields Medal, and they formalized it. I mean, a few years later in Lean, the results. Well, the definition of what is a perfectoid space in Lean. And this was a lot of people look at Lean because of that. I mean, saying, and Kevin was telling the world, look, you can formalize cutting edge mathematics in this system. When you do that, you can visualize the mathematical objects from many different ways, right? I mean, and he starts going around giving talks, and then came the liquid tensor experiments. That was the inflection point for Lean.
That was the one thing you pinned down in that year, in that period that kicked things off.
Oh yeah, yeah. After
Okay.
the liquid tensor experiments, lots of people start paying attention to Lean, right? I mean, this was a result. It's also Peter's results. I mean, that he was unsure about the results, and nobody was checking. The complexity was too high. Even him, he said that he could not keep all the objects in his mind simultaneously. It was too hard to keep everything, all the details in his mind. And people managed to do it. I mean, and it showed up in Nature. Peter has really nice quotes about Lean, saying that it helped him to control the complexity. Many lessons learned, people working together, right? Was also big news. People thought it would take years. In a few months, Johan Commelin led the project. In a few months, they managed to formalize the key results Peter was unsure about. People thought it would take years to do it, but people working together could do it, right? Because there was a checker there, Lean checking. Another cool thing that Johan said is that I think is really important is like he could see only 2 steps ahead in the proof. It was key to have an assistant there guiding him. Another thing that blew people's minds is that they did not only formalize the results, but they also simplified the proof without understanding the proof. Is that you need an assistant. I think even Peter probably got really impressed that people simplified his proof. Right, so it's like he factored the proof.
Yeah, it was a big achievement at the time, and even today, impressive. Just then, at about that time, give or take, 2017, Mathlib was created, if I'm correct. And today, it's the biggest formalized library of mathematics online. I guess, can you share a bit about why it was separated out of, I think, Lean 3 and how you work alongside Mathlib and Lean Fro today?
At the beginning, everything was in a single repo until 2017. The library and Lean were together in the same GitHub repository, right? And I was the only maintainer. I mean, some people have the misconception that they say Lean is a Microsoft project. They don't understand that it's Microsoft research. You have autonomy. I mean, you have your own projects. I mean, I didn't have to ask permission to anybody to start Lean. This is great, but you also do not have a team of engineers helping you. You're doing by yourself, right? And we had community helping. I mean, external contributors helping, but I was the one managing the repository by myself, and it doesn't scale, right? I mean, you have all these peers from math coming into the repository. You're trying to develop the tool. It feels natural to split where you have in one repository the core language, right? The compiler, the environments and everything. In another one, you have the library. The Rust start library. There are many programming languages that use the same splits, right? They don't put everything together in a single repo. And that was great. I mean, in 2017, it was super hard to do it. Now it would be impossible for one human to do it. Now they have, if you go to the Mathlib maintainers page, they have an army of reviewers
Yeah.
and it still now is a bottleneck. Next year, we're going to be celebrating 10 years of Mathlib. One big topic is how to scale, right? I mean, how to decentralize, people can move faster, right? Especially now with AI.
Yeah.
Yeah, the progress will accelerate. I mean, but centralization is bad for moving fast, right?
Yeah, it's just trying to find the balance, isn't it, really?
Yeah.
Moving on to another big project. In, I think, the early 2020s, essentially there was a big project to move Lean to Lean 4, which was not backward
Yeah.
compatible, which is a big, big upgrade. I guess what was holding back adoption and what the Lean 4 fix? What were the key kind of things that it improved?
Yes. Yeah. Yeah. Uh, in Lean 3, we saw a few limitations. I mean, Lean 3 was the first one that was extensible. You could write some extensions. You could not extend every part of the system. You could extend some parts of the system using Lean itself, but it was an interpreter. The performance was equivalent to Python. It was faster. It's faster. It's still faster than Python Lean 3, but it's slow. There were limitations on the kind of user notations you could have, and math community loves to have their own notations. The metaprogramming had limitations. We had problems of scalability all over the place. Uh, it was a good time to start a new one. We now was clear in my mind how to build a proof of systems, all the issues, what we should pay attention to. And Sebastian Uli and I, in 2018, we decided to start.
Oh, wow.
Mathlib was only 40,000 lines of code. And we felt at the time saying, it's not going to be backward compatible, but we can rewrite from scratch if you want.
Yeah.
But when we finished Lean 4, we made it public in 2021, beginning of 2021. It was 1 million lines, Mathlib, at the time. And we said, how do we port this stuff? People thought it was impossible to port. That would not happen. It would be like Python. But again, the community did it. I mean, they managed to do the ports. I mean, in 2023, it took like a long time. I mean, because it was not backward compatible, there were many features being added to Lean 3 by the community. In this way, we had to make sure that everything that was available in Lean 3 was available in Lean 4. We had a long time making sure that we had all the pieces in Lean 4 to make sure the port was even possible. But in August of 2023, no, July. In July of 2023, the port was done, and the port was finished at the exact date of commemorating 10 years of the first commit to the Lean repo. It's by accident. It was not planned. Exact date, 10 years later, the port was finished. And Patrick Massoa has a beautiful video celebrating. It's really cool.
That's it's an impressive
Yeah.
achievement and a good way to celebrate 10 years. Moving gears a little bit now. how hard is it to write lean? So let's assume I'm an undergraduate maths or computer science student with competent coding skills. How long would it take me to learn? And from the creator himself, any
Mhm.
advice on how you would accelerate that?
Okay, yeah. If you have background in functional programming languages, is instantaneous, right? It's super easy. If you have used Haskell or Camel programming F sharp, super easy to learn, right? I mean, if you have never used a functional programming language, I would tell the students, oh, follow. We have a book called Functional Programming Lean. It goes step by step. It's really well written. It was written by David Christiansen. He works as the Fro now. He wrote before he joined the Fro. He's a really good writer. People love the book. I would recommend this book.
Okay.
But one trick now. A bunch of people are learning to use Lean using AI. Claude, ChatGPT, all these AIs, they know Lean really, really well. They can guide you, they can write stuff for you, they can single shot really uh, 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 non-trivial programs. I mean, I'm super impressed with AI. I mean, we're going to talk about AI probably later, but I would say if you want to learn use AI, just keep talking with the AI. It will teach you. For example, Terence Tao told me he learned it by using two windows, one with ChatGPT, another one with VS Codes running Lean, and he kept asking. And now the AI is even better. It's integrated. You don't even need to have two windows. In the
Yeah.
same window, you keep talking to the AI, everything goes smoothly.
It's reassuring to hear one of the world's smartest people is also using
Yeah,
using
yeah,
some of
yeah.
these tools. And then with respect to the models, how do you benchmark them for? I mean, you're the best tester of how good they are. Is the output, ballpark 90% good? Is how accurate, I guess, is it when you ask them to write a lean statement or produce lean today?
No, it's mind blowing. It's mind blowing. I mean, the last few months, the latest models are mind blowing. They just not create proofs for Lean. They help us develop Lean itself. The amount is is incredible. I would not. If you had asked me 6 months ago, I would say it's impossible. The behavior I'm observing now. I'm going to give you one example. Uh, Kim Morrison, we worked together for a long time in Lean. Kim tried the following experiments. They got zlib. Zlib is a popular C library for compression, right? They asked Claude, convert zlib into Lean, make sure it passes the test suite, then prove that if you compress a file and decompress the file, you get the original file back. I would say, come on, this is not going to work, right? Claude did it. Claude did it.
Single shot?
No, 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 no. Claude Code. Claude Code. It
Yeah.
kept running for 1 week, and there are many commits, and but autonomously, right? I mean, uh, 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 I would think this was impossible 6 months ago. I mean, uh, of course, I expect probably Claude retrieved the spec from zlib from the web, the specs. It retrieves information. It's not just the C code; it's a mixture of
Yeah.
the C code, but it uses the test suite and completely autonomously, right? And this is just the tip of the iceberg. Progress is going to accelerate. So, yeah, it's really hard to predict what's going to happen.
What do you think? 6 months ago, you said you wouldn't have thought this was possible. What do you think has specifically driven this improvement in the most recent models?
Yeah, it's hard to tell. I mean, I don't think Anthropic trains uh, does not have a reinforcement loop on top of Lean. I don't think this is the case. I talked to many different people. Uh, they told me they do not have. This is just based on the training data available online, right? I mean, for sure, they are the Zulip channel for Lean, where we discuss Lean. the GitHub issues, the code base, the usage, all that. But the behavior, there are bugs Claude fixes in Lean, spot on. I mean, I looked at the explanation and said, wow, I think none of the other Lean developers can understand this explanation Claude came up with. And it's precise, everything is correct. It understands parts of the code base that most other developers do not understand. I mean, it's incredible. I mean,
Good. It sounds like Claude is also supercharging lean development, which is a
yeah. I cannot. Another thing, for example, that people don't understand the pain. I mean, one of the most painful things we have is when we change lean, even if the change is for the better. It breaks the libraries, right? I mean, you have a proof got shorter. You still have to fix things,
yeah.
right? This is not fun work, right? I mean, Claude helps us a lot doing that. Isolating issues is also not fun work. I mean, it's mechanical. Another one, when people send us, there's a bug here, it's a gigantic file. People don't want to bother minimizing the issue and creating a minimal working example. Claude does that for us today. I mean, I cannot even imagine. The pain is like I have loads that is removed from your back, and life's so much better for us. I mean,
That's good. You're living the AI revolution too. Um, in your most recent essay, you highlight that the obstacle to formal verification has always been cost, and that
mhm,
AI changed the economics, which is kind of what you're saying already.
yeah,
Can you just walk us through what that shift looks like with respect to, formal verification?
yeah. I mean, keep in mind, these lib experiments. We just learned to use these tools, right? I mean, the inflection point was like happened a few months ago where all these models got much better. We're just learning to use our workflows are changing, right? I mean, DC Lib is like we're being amateurs trying this tooling for the first time. We can do much better. We did not set up any special skills, I mean, or MCP servers. We did not do anything special. We did not put created virtual machines, sandbox everything, let it run wild. Uh, uh, we use a regular Claude accounts, Max accounts. We did not use special token, the APIs. We didn't do anything special. We did not try to optimize Lean for AI, right? Lean is optimized for humans now. You can optimize it for AI, and we want to do that. I, I feel like it will change dramatically. I believe in the future it will be really rare. I mean, people are going to work at the spec level, very high level. They're going to maybe help. I mean, maybe I don't know how far AI is going to go if just stay at this level of intelligence. We can see humans working at the very high level, right? And AI taking over all the grinding, the mechanical steps, painful steps. The AI will take over, right? It's going to be much more cost efficient. And, for example, another thing that people are just trying to do, we have these specialized AIs that are built for Lean, like AlphaProof, Aristotle from Harmonic, and these general purpose AIs they call. This week I saw some. I forgot the name of the person that posted, but they said, "Look, Claude called Aristotle. I mean, because Aristotle is going to do search. I mean, the round trip is way faster than Claude. Claude would call Lean. You start a lean process, load Mathlib that is ginormous, get an error, and then try again. It takes several seconds which each iteration. Tools like Aristotle and AlphaProof, they work inside of Lean, right? They control the search tree. And they are way more efficient. We're already seeing people combining general purpose AI with domain specific AI built for Lean. Right? I mean, Yeah, it's going to be wild.
Yeah, I guess there's sort of the tool chaining there, right? That's
Yeah.
a new thing. Interesting. I've spoken to a few people at various points about lean and where it's going, and
Hmm.
some on the extreme end think we should formalize everything,
Yeah, yeah.
hardware, software, the legal system itself. Um, just going outside domains like math. Like, what are the challenges to adoption? Is it the specification itself, or are there things?
No, for hardware, I think the main challenge is scalability. You have to make sure that some parts that are just work, right? We need Verilog front end, for example. Most companies are using Verilog. Or you need high-level languages that map into Verilog. But you need the tool chain, right? You need someone has to build the tool chain. Another thing is you have to make sure Lean scales for this kind of design, right? That is massive in size, right? Uh, uh, it's a different kind of complexity, right? You have complexity like the one in math that's really cheap, complex objects. And there is complexity in hardware, software verification that's more about the size, right, of the design, right? Uh, uh, but we're actually working on that. It will happen. We're fully confident this will happen. Uh, 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 Imagine the upside is amazing, right? You can imagine that after, suppose that this works, you can really verify hardware with AI. You can do equivalence checking with AI. Now you can let these things run wild, trying to optimize the designs and proving the equivalence to the reference one, right? Yeah, I think the upside is incredible, right?
But it's just convincing people that now is the time to start implementing
Yeah,
these.
yeah.
Interesting.
No,
Right.
because in the past was, I mean, suppose that you try this approach in the past, right? You have a reference model of the hardware and you have the optimized version. You want to prove equivalence. You had some tools, but the tools don't scale. You had to do manual steps, and it's a lot of work. But if it just becomes free, the AI is doing it for you, and it can handle complexity, massive amounts of data. Uh, then it changes completely, right? The landscape.
Interesting. Um, with respect to Lean is itself a fully functional programming language.
Mm-hmm.
So in theory, you can build general purpose software. What's needed for that to kind of, you know, that broader adoption to happen? Is it more community contributions to foundational libraries? Is it more awareness outside of, AI math community? Or what are the two things, I guess, you think needed to see this take off for more
Yeah,
general purpose?
yeah, libraries. Number one, libraries. And I think AI will start helping. People are going to start building not just math libraries more efficiently because of AI, but also software ones. We're going to see an acceleration there. Uh, for high performance applications, uh, the performance of Lean is equivalent to C Sharp or Camel, of what we call managed languages, right? It's not right now as efficient as Rust and C, right? But we are going to see a movement. We are working on improving the code generator, but of course, there are limits to what you can do in a language like Lean. We want to have in the future embedded languages inside of Lean that you have is like a super close to the metal, right? Like even lower level than C that allows you to write really efficient codes. And we are betting that it's AI that's going to be the writer. There will be not the programmers of these low level languages are not going to be humans, but AI. And the humans are going to work at the spec level, writing the models in C, and the AI will take over and write into this low level language that has a semantics written in C that you can prove the equivalence. And that's what we are betting. And having everything in a single system where you can reason about this high level language to the low level one, show the equivalence. We think this is the key differentiator for Lean. right?
And again, AI unlocks this, right? The productivity gains,
Yeah,
the less steep learning curve, um,
yes.
co-writing specifications, things like that. Um, is there any plans to develop a Lean 5? Or is there
No,
too
no,
much?
no, no. Yeah, let's explain that. I mean, this is an important point. Uh, uh, Lean 1, Lean 2, Lean 3, Lean 4, they're not, they're discontinuities in the development cycle. It's like you have something now that's incompatible with the previous version. Uh, we have now, the difference now, we're actually, I mean, what we have done from Lean 4 to now is way more than we have done from Lean 3 to Lean 4, but there is a continuity there happening. There's no discontinuity happening in the developments where every single Lean version now, Mathlib is moving together, the whole ecosystem is moving together, right? I think the way to put it is one day we may rename Lean 4 to Lean 5, right? I mean, but there will be no discontinuity, right? This is impossible now. The ecosystem is too big to have a discontinuity. We are moving together, right?
Yeah, that makes sense. If a company were to come to you tomorrow, startup, scale up, big company, and say, Leo, we want to implement this, what will be the starting point or the resources you point them towards, and things that they should
We implement what? I mean, what's this here?
start using formal verification and Lean
Mhm.
itself, to enable them to develop more safe, more secure, more robust
Mhm.
software. Start
Yeah,
with.
I point some examples of projects that's and we tell them, look, try to use AI to try a small example. I mean, you're probably trying to develop software in a specific area. Try to develop a prototype using AI. In 1 week, I bet you can have something working. In 1 week, and from there you evaluate whether it's ready or not. If it's not ready, tell us what's missing in Lean, and we're going to add. That's the Lean flow.
Okay. What is the biggest misconception, I guess, for people outside the field about formal verification and Lean? Is there something that stands out where people hesitate, or is it the fact that it's complex? If you're not in this ecosystem.
Let's see. Simply for me, I mean, it depends on the background, right? I mean, uh, some people have used Lean a few years ago and they have this mental model of Lean a few years ago. They don't see the velocity things are progressing. When people ask me, I say, look at the last few years since we launched the Lean Flow, right? The non-profits. Look at the velocity. Look at the release notes. Do you think it's going to slow down or do you think it's going to accelerate? It's going to accelerate. Where the whole info is using AI to develop Lean now. It's
Hmm.
going to move way faster. Look, the velocity is super fast, and now it's going to be even faster. I mean, I tell people, look, if you want to bet on Lean. Look at the history. Compare the history of every single project, competing project. Don't take my words. Look at what's happening, talk to the users. I mean, see what they tell you about the weaknesses, the strengths, what they are observing, how fast Lean is moving. Don't take my words. Look at what is happening. Look at the data.
I guess you can see that with the growth, even with
Yeah,
Mathlib and
yeah,
other pieces that are related to it, right?
yeah.
Okay, a few more questions there, but imagine it's 2030 and we're sitting down for a follow-up version of this podcast. Help me imagine where Lean is 4 or 5 years from now, how it interacts with the world, and in your mind, if you have again that time travel machine to move forward this time, where
Mhm.
would Lean be in 5 years, and what will have been the key to its success?
Yeah. Now, I mean, I could 5 years ago, I could was easier to predict 5 years in the future, right? 5 years ago. Now it's really hard. Things are moving so fast. But I can tell you, awards may even happen earlier than 5 years. I mean, because things are moving so fast, is that most users, there will always be users that are writing Lean directly. But we can imagine a world where most people are not writing Lean, they're just reading Lean. The AIs, they're explaining in natural language what they want. Uh, they are writing stuff on the whiteboards, taking pictures, and maybe they even have a camera attached, seeing what they are writing down. They are converting this into nicely written math, auto-formalizing everything. Everything's perfectly typeset. They're using LaTeX behind. You don't know, nobody uses LaTeX anymore because AI is way better. It's way better than any human writing LaTeX. We're working in a very abstract. We're maybe talking to the machine and it's converting our ideas into formal. But one thing people miss that's important: Lean guarantees that your proofs are correct, but it cannot give you any guarantees about the statements of the problem. I mean, you may say 2 plus 2 equals 4. This is the statement of Fermat's last theorem. You can call it, you can give the name, this is Fermat's last theorem, but it's just a fancy way to say 2 plus 2 equals 4. There's no way to validate that. You as a human, you are responsible to say, this is these formal statements captures my understanding. One point I make to everybody is that reading specs written in Lean is way easier than writing them. It's much easier. All you can ask any person in the math community, they say, reading the statements, I learned very quickly. And keep in mind that you're not going to read them by yourself. There will be AI there helping you to understand what's there. But in the future, we will have to be able to read Lean, for sure. We are going to have all this tooling around it. For sure, there will be AIs. You're going to have armies of AIs assisting you in this process. Some people will try to dig deeper, right? I mean, to write Lean themselves and create programs. There will be this kind of people, for sure. But this is like a tiny percentage of the user base that will be like that. Most people are going to be working on a much higher level of abstraction, right?
So the challenge is, as you pointed out, is writing the statement itself or the specification and ensuring it
Yeah,
captures the intent. But
yeah,
will that be AI assisted largely in the
yeah, yeah,
future?
yeah, yeah. For sure, it will be, for sure. You can feel like you are interacting with the AI until you converge to some formal model of your intention and you say, yes, this is what I want. And from there, the AI takes over.
And for that to happen, if someone doesn't actually understand the lean, is it trusting that the AI can capture the statement and translate it correctly? Is that enough, I guess?
You mean like if there is, there will be a point that the AI keep failing in converting your
There,
explanation into formal.
exactly, yeah. If that happens.
Well, yeah, but today it happens. I mean, some people will go there and write themselves. You're going to ask, but I don't see the progress if it keeps going the way it is. I
Yeah.
don't see. I mean, the AI can do already incredible. Even if it stays like it is today, that I don't believe is going to be the case, is already super, super good. Uh, 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 I cannot even imagine learning any subject without AI assistance. I mean, it's so much faster, right?
Yeah.
Uh, Going through Mathlib is incredible. Open any random Mathlib file. Ask the AI to explain the proof, what this object is. It's beautiful. It's beautiful, the explanation. Yeah, and this is with today's technology. It will not stop here, right? You will get cheaper, faster, more powerful.
Interesting. Where can people learn more about lean and the community and any any ways that they can think about contributing?
Yes, yes. I mean, our website is lean-lang.org. Uh, There you're going to find all documentation about Lean. You're going to learn about the Lean Flow. The Lean Flow is a non-profit behind Lean. Uh, we're constantly fundraising. Lean is a non-profit, right? I mean, we need donations from philanthropists, from big tech companies, startups. This is all important, right? Every donation helps the mission, right? I mean, if you want to help, go to, we have an email there, contacts at lean-flow.org. You can find it on our website. Yeah, contact us. I mean, every donation helps the mission. I mean,
It's I think going back to the previous question, I think what gets you to 2030, 2031, probably community and all of the wonderful contributors and the team
mhm.
itself pushing things forward, right?
Yeah, yeah, yeah. And now there's a really healthy ecosystem, right? We have the Lean Flow, that's the non-profit that develops Lean itself. We have now the Mathlib initiative that is led by Johan Kommelin, is responsible for making sure we are going to scale Mathlib developments, coordinating all the efforts around Mathlib. We just launched CSLib, right? CSLib is like Mathlib, but for computer science. We are super excited about it. And the ecosystem is growing, right? I mean, we have all these initiatives now. Each of them are independently managed. I mean, and I think that's the sign of a healthy ecosystem. I mean, all of them needs donations, by the way. I mean, it's not just the Lean Flow. Mathlib is super important. All these revolutions happening because of Mathlib. The Mathlib initiative needs support too. Same thing for CSLib that just started. And
Yeah.
the libraries, I mean, we're trying to also launch a library for physics that is funded. I mean, there's Fizzling now. It's getting popular, but it needs support. It's basically one person driving.
Yeah. Okay. Leah, thank you so much for your time.
Thank
For
you.
anyone listening who wants to learn more about Lean or get involved in the community, we'll put all the links Leah mentioned in the show notes. This has been a Latinum podcast. I'm Brendan, and we'll see you next time. Thank you very much.
Thank you. Thank you.